And we will talk about quite old technology. Like, can we have a quick poll? So, Jean-Mi, can we have? Yeah, nice. That I like that because like you cannot see me anymore, but I can see you. That's, oh. Thank you, Jean-Michel. So, who started to learn database programming using Core Data? Sorry. Yeah. Okay. That. No, learning. Like the first experience, like for a lot of people at the beginning of iOS and macOS apps, where you were actually almost obliged to have a core data stack. So it's gradually faded away. I think you can turn off the room now. It changes now. We all kind of forgot that. Almost all of us forgot that core data can be used as a database, and we are more using more light approaches, like I don't know, caching the server answers or using a SQLite or whatever. But I think there's someone here who is telling you, who will tell us some good news on what is going to be, what is new on core data, and Abizer, who is probably known for some of you who live in London for being the organizer of a very cool meetup in London, will tell us some more about this old technology that is not dead yet. Thanks, Abizer.
Hello, I'm Abizer NASIR. I'm here to talk to you about why core data isn't dead yet. So I'm going to just talk to you about why it's still relevant. There's been lots of changes. I'm sure lots of you don't use it or you don't feel like using it. So if you're new to this, I hope you learned some things because I've got some basic stuff in there. And if you're an experienced core data developer, I hope you learn some of the new stuff that I'm going to show you. So core data is, well, it's basically used as a model layer for your application. It's not just the persistence of the disk, because that's what most people think of when they think of core data. It's a database, which it actually isn't. But you think that it's all about storing the data to the disk, but it isn't. It's not just storing the data to the disk. It's the objects that you use as your data objects in your model. It manages that, manages the memory life cycle. And basically, we don't really think about saving the data to disk, because that's just something that happens, hopefully. But it's more about the objects and how you work with them and how you use them in your UI and your application. So to start off with, some of the reasons why people don't use core data, it's fairly big. It's very big. The SDK is about that much paper if you print it out. There's been books written about it, and it's quite complicated. Also, if you're working in a team and not everybody in the team is comfortable with core data, then it's quite hard saying, oh, let's just put core data in because they feel that it's perhaps too much or it's overkill or there are other solutions available for it. It's closed source. It's by Apple. There are bugs. Performance problems are traditionally hard to find and fix. And also, I know some of you said you learned to use core data. I'm sure every single one of you has been burnt by it. And yeah, I'd be lying if I said I haven't been up late at night trying to figure out some problems. But there are alternatives, and I have actually seen these. I've seen people put their application data in user defaults. I'm a contractor, and I see a lot of bad code and I'm asked to go in and fix it. And yes, I've seen data put in user defaults. NSCoding is probably an older mechanism, and it's also quite useful for just storing application-level data, but nothing that's really dynamic and moving about. And that's really quite good for it. Magical record is something that's been around for a while, and it was basically the idea of putting active record on top of core data. So people who came from the Ruby world or people who just like the active methodology would be comfortable with it. I was never a Ruby guy. I was never a big fan of magical record. I think when the multi-tiered and the multi-threaded core data stack came out, it was very useful for vending you the private context and the main context. But in general, even at the time when Saul Mora presented it, and I saw him in London, he was saying that's really a main course for that. But that was a couple of years ago. The only alternative I would probably say you could use is Realm. I have used Realm in an application. I found it quite pleasant to use. easy enough to set up, good support, and the people who work with it are actually really nice. It is open source, it's cross-platform, it is fast, and it handles multi-threading quite well. And basically setting it up is a doddle. Even if you're not using CocoaPods, it's quite easy to set up. And there's lots of plugins, so if it's not there, things like EffectResultsController and stuff have been brought in. But Realm isn't core data, and that's not what I'm here to talk to you about. I'm a core data guy. If you've heard me speak before, you know that I tend to be very vanilla in my approaches to work. I try to keep things simple, try to keep things with what's available on the system, and core data is on the system. Oops. And also, core data is large because it's powerful and it is flexible. You don't have to use everything that it provides. I've certainly not used everything it has to provide. I mean, I'm aware of things like using multiple persistent stores, but I've never actually done it. I'm aware of the times when you need to use it, but I've never actually done it. I'm aware that you don't have to store things in SQLite. I'm aware that you could write translators to persist your data in other formats if you want to. I've heard of people who save it to CSV. But it's possible to do, but that's why it's so big, because you can do this. So as I said, it's part of the system. The advantage of it is, because it's part of the system, and as it comes out with a new SDK every year, the core data that you get is up to date. You don't have to wait for an update. Of course, that means you have to change it, but that's another thing. But it's always available. It also works across all of Apple's platforms. It works on the TV, the phone, the watch, the Mac. I've written applications which have been multi-platform. I've put my core data stack in a framework and just shared the framework about the apps. So I could have a versioned model layer, so to speak, and still share code. So that's really quite easy. It also, because it's integrated with the system, it takes care of the memory pressure for you. It's optimized. It's very, well, it deals with its own memory. It deals with its own caching, so that by the time you get this did receive memory warning message in your view controller, there's nothing you really need to do to lighten your core data use, because core data has probably already done it for you. And also you've got NSFetchResultsController, which is really useful for driving table and collection views. There's UI managed document for document-based applications. I'll talk about that later. Some of the things that you get with core data for free. Memory management with faulting. I'll speak a little bit about faulting later. Change notifications. Core data, if you listen to all the notifications it sends out, is very, very chatty. You can subscribe to the notifications on different contexts, all contexts, particular models. Basically, it updates you with notifications a lot. But a good thing is that if you change the data that you're using, one of the things I'll speak about in EffectResultsController, it tells you what has changed, where it has changed, and how it has changed. You can get undo and redo for free. On iOS, undo is turned off by default, and I think in Mac, in the new versions, it's turned off by default as well now. Also, your object validation, so by the time you come to save your data, if you put validation rules on it, it will take care of that. Well, take care of that. It will tell you what you've done wrong. You've still got to fix it. And because it's not a core data, it's not a database, it's an object graph, and so if you add something with a relationship, it'll take care of joining up both of the entities together. So if you started with core data, or you've just started looking at it, or you've looked at it in the past, this is what you've seen, the core data stack. It's not really that scary. I mean, you've got big words in there, but it's not really that bad. You've got the persistent store, which is where the data is persisted. More often than not, it's a SQLite store. It doesn't have to be. It can be in memory. On the Mac, you can store it as XML or just as a binary blob. But more often than not, it's SQLite, and that's probably the one that gives you the best performance. And this managed object model is where you describe the data. You describe the properties of your objects, you describe the relationships they have between them, and you sort of define the validation rules, indexes, things like that. The NS Persistent Store Coordinator does a lot of the heavy lifting for you. What that does is it takes the information that's stored on disk or in memory from the persistent store, and it marries up that data with the description that you've provided from the managed object model. and it passes it up to the managed object context. And on the way down, it deals with saving it by taking the changes, reading the model, deciding how it has to be stored, and takes care of that. Then you have the managed object context, which is the object that you deal with most. This is when you're changing data, adding data, manipulating your data to get it onto your views, or saving data. You're working with a managed object context. You used to have to worry a bit more about persistent store coordinator, but you don't have to do that so much now. Well, ish. When you start with, you really don't need to worry about it. When you start looking at performance problems, well, performance optimizations, sorry, you do need to look at how you're interacting with the persistent store coordinator and the store. So this is one way to set up the stack. Don't bother reading it. You can download the slides later. And it's just one way, because you have to set up the stack with the persistent store, the model, and stick a managed object context on it, set properties up. That is something that is not nice to do. It's a big chunk of boilerplate. New, we have NS persistent container. It's a lovely little class. It's a much simpler way of creating core data stack. And it has sensible defaults. It takes care of where it's going to put the stored data appropriate to the system. So it'll put it in the application resources directory on the Mac. It'll put it in documents on iOS, the cache on the TV. It provides convenience methods for dealing with multi-threaded objects. We'll get back to that later. And also something that you may have been bitten by if you've used core data before is when you have migrations to do and they take a long time, you may be blocking the thread or the Springboard process kicks you out because of time. And so you tend to do the loading in the background yourself, or you put it on an operation queue. Now it just loads it asynchronously. So from that big chunk of text, this is all it takes. You define your persistent container, which is the bit where it's stored, where you set up the defaults of how you want it to, whether it's a SQLite app, by default it'll be SQLite, and by default it will have automatic lightweight migration enabled. You tell it the name of the model, which is the XE data model file in your Xcode project. And then you run this, oops, I get to use this. You get to run that message, which loads of persistent stores. It stores, because you can have more than one, and it just runs this block. And then when it's done, your stack's ready to use. But you return the container straight away. So the asynchronicity is dealt with for you. Managed object models are how you describe your data. You generally do it in a UI very much like you do with storyboards. I don't know how you feel about storyboards or nibs, but really, if you're going to deal with managed object models, you're going to deal with it in the editor. You just define the properties and relationships. And then it has a graph view as well, so you can see how they're all related together. I said earlier that core data isn't a database. It uses a database for its persistence when it saves it to disk, but that doesn't mean it's a database. You don't think of it in terms of tables and joins and IDs and how they match up. You think of it as, I have these entities and they're related to each other. And the important thing to notice here is they're double-ended. So each relationship has another side. So if I have one object which is a many to one-to-many to one object, the other one is a one-to-one on the other side. Another thing that gets you, you may think when you're describing your models that you have a common object and you're going to use subclasses, which you can do, but bear in mind that when you actually create the table in SQLite, it creates one big table, and it's very sparsely populated with all the properties. So it may not be what you want to do. Right. So managed objects are the actual data objects. Although they're managed by the persistent store coordinator, they're put into the managed object context, which is where you work with them. Something you need to worry about is that you can't use the managed object between threads. So if you've created a managed object in your main thread, you can't pass it off to a background thread and use it there, and vice versa. The only thing you can do is you can pass the object ID across, which is a unique reference, or how you get uniquing. And so you pass the object ID to another context, and you tell that context to load that object with that ID. It's a lot simpler than it sounds. But there are changes again with managed objects. Used to be a lot harder to set them up. Now it's really simple to actually initialize them. The initializer is basically init context with a managed object context. So if you have a managed object, you just say, here's the context I want it to initialize in, and it will create it. Note it's just an initializer. You're not setting up any properties or relationships because that's defined in your model, and it doesn't really settle itself down until you fill them in. So you don't really override the initializer in core data. You do it in awake from insert or awake from fetch. But don't worry about that for now. Essentially, it's a lot nicer. If you've ever had to do it the old way, this is a lot simpler. And also fetch requests. You don't have to generate your own little fetch request convenience methods now. They come straight off the managed object. So you can say, I have this managed object, give me a fetch request, and it will deal with that. If that sounds strange, I'll get to that in a minute. Also, if you've used core data, you've probably heard of MoGenerator. Because when you create the managed object model, essentially it's an NS object, and then all you're ever doing is accessing it using value for key or set value for key. And so to make it easier, you create subclasses. But if you generate a subclass off it, which Xcode will do for you, every time you change the model, you've got to go into this subclass and change it and tweak it around a bit more. And it becomes a bit of a pain. So Wolf Wrench, years ago, came up with MoGenerator, or Managed Object Generator, and it took your model and it generated basically a class hierarchy. It created the one that was machine generated, and it gave you a stub empty file where you could write your own extra parameters, your own extra properties, and functions on it. Xcode 6 and 7, I think, made it easier. You could generate it directly, and then it did things with categories. What they have done now is that when you generate your model, you can actually set it up so that it doesn't actually create the code in your project anymore. It just creates it in the derived data folder, and you never actually see it. The advantage of that is if you change it, it just regenerates in the background. And if you select this option, it will generate the class and the category, so it will generate everything. And that's basically, it's as if you're using the NS managed object by itself without any extra methods or properties. You just don't want to use key value coding. If you use a category extension, it will generate the category extension class in the derived data folder, and you have to derive a class, which is the main class, with your extra functions and properties. Also, because these are in the derived data, if you start getting problems with it, we're all used to just killing our derived data folder and then just redoing it. It's nothing new. So when you have managed object contexts, as I said, managed objects can only be dealt with on the thread that they're created in. That normally means it only really works with the managed object that it's been created in. And lately it's been tightened up a bit, so you can only really create a managed object context with a concurrency type, which is either a main queue concurrency type, which it runs on the main queue, which is the UI queue, and so objects from here can be used to drive your UI. And this persistent container's got a lovely little parameter called viewContext, which will just give you that context. So you don't have to worry about creating it, you just ask for the viewContext. Oops, that one. The private queue concurrency type lives in the background, and it's useful for performing background tasks as you'd expect. And again, NS Persistent Store provides a method called new background context, which will create a new background context that you can work with. However, it's got this other method called perform background task. It takes a closure, and so you can just give it some things to do, and it will take care of creating the private queue context for you, and it will take care of running it on the main, on the right queue. So, how do you get an object out of the store into the managed object context where you can deal with it? Something called a fetch result, and you deal with it quite a lot. It used to just return an array of NS managed objects. Now they've made it generic, so you actually get a type back so you don't have to cast it. It looks like this. It's really quite simple. If you remember Oliver's talk, you realize that I'm giving it a little hint here, so it knows what type this returns. You give it a sort descriptor, so it knows how to sort the data when it comes back. You give it a predicate, if you want to, that's optional, which basically is a filter. It's like filtering an array, except you do a predicate. And then you add an array of sort descriptors. You add an array because they apply them in that order. You give it a predicate. I'd like to point out, it's like a little key path method there and there. It destringifies it a bit more. So 3 does all sorts of things. And then run the request. It's quite simple. I do it this way so that I return an array. And then you just, whoops. And then it's just try, get the main key context, fetch it, and that's it. And there's your results. You do something with them. Then we have NSFetchResultsController, which is a lovely beast. It's really useful for dealing with table views and collection views. And all the things that you write in your data source, like how many sections do I have? What are the names of the sections? How many rows do I have for this index path? Which objects belong to which index path? And it listens to the changes in the context. So you can do these really nice things, which I use it quite a lot, but a little bit of pseudocode. So basically, the NSFetchResultsController has a delegate method, which is told when it will change objects in the context. And all you need to do then is say, table view begin updates, so it's ready for the changes. And then it says, these are the objects I changed. I changed this object at this index path with this change type, and there may be a new index path for it. So I can do something on an insert, delete, and move in an update, manage your rows. And then did change content, simply just end updates, and all the changes are pushed through, and you don't get any of those index path number count before or after malarkeys. Faulting. Strange word they use, faulting, because you see these error messages and it's saying, could not fire a fault. You see fault, 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 and for an English speaker, fault means a defect or something wrong. It's not really what it is. Part of what makes core data fast is that when you ask for an object and a fetch request, it doesn't automatically pull in all the parameter values and all the relationships. It's like, I know there's this property, but I'm not actually going to get it for you until you ask me for it. It doesn't go all the way down, but it doesn't have to go all the way down to the disk to get it sometimes because it does do some caching, but essentially it's not there. So it's like a promise that when I ask for this property or ask for this relationships property, it will be there. But again, if you've used core data in the past, you used to see this quite a lot, something called could not fulfill a fault. So faulting is really good because it doesn't have to pull in all the data all the time if it doesn't need it. Unfortunately, what happens is that something happens to that faulted object in the background or somewhere else that you're not aware of. And then when you go and try and fire the fault or get the actual value for it, it's not there, and it pops this up. And this is the sort of thing that keeps you up at night. Normally it happens on a background queue. Something they've changed recently, query generations. What this does is it pins a context to a generation of data. So if I have a core data stack at this sort of, or properties and objects at this state, this is the state that I'm going to say my managed object context deals with this view of data. You pin it by doing something like this. You get for example, I'm using this in the main context. I'm setting a query generation from, I'm just saying use the current one. I can actually pass in a real one to use, or pass in nil when it will just use the default and you're dealing with your faulting yourself. And that's it. Once you've done that, then if you fire a fault on so if you access a property or a relationships property on a value that you already have in your fetch request, it's actually going to fulfill that fault, even though that object may not be there. Hopefully that's going to save a lot of trouble. The good thing about this is it's sort of lightweight. If you do any more fetches, it'll just get the most recent version and it'll update the generation. Also, if you do any saves or resets or handle any of the merge notifications you get out of core data, it deals with that as well. And it will just update the generation. If you've told it to use current, if you've actually pinned it to a generation, you can ask a managed object context for its current generation and pin it to that. It will just stay there and not move, and you can use that data until you're ready to update it or just passing in a new version. Finally, let's talk about iCloud. Right, the title of my talk is Core Data. It's not dead yet. Well, unfortunately, it is dead on iCloud. It got deprecated. didn't get mentioned in WWDC video, but it's in the release notes that they've all been deprecated. So if you look at them, they've got nice little red lines through them. Now, if you look at the release notes, they say it's going to be available for a while, and this is just the code in the SDK. The server-side code will still work, and your applications will still work for iOS 9 and 10, however long people use iOS 9 and 10. As usual, we don't know when it's going to go. So, yeah, if you're thinking of writing an iCloud document application with core data, it's not going to happen. Maybe they'll do something new. Maybe you'll just have to do the CloudKit stuff yourself. Or ensembles, and you can pronounce it how you want, ensembles.io. That's another option which takes care of it for you, supposedly. It's supposed to be quite good. I've never used that if I had to. I think I'll just finish off with some references. As I said, core data is quite large. Core Data in Swift by Marcus Zara. It's been, well, maybe not the Swift version, but the Core Data in Objective-C book was the one I learnt core data from back in 2009, I think. Goes into quite a lot of detail. As you can imagine, some of the stuff is a bit out of date in terms of the new stuff, but it tells you a lot of details about how everything ties together, how everything sticks, what core data is doing under the hood. It's a really handy reference. A newer version is the Objective-C IO guys. They've done their core data book. That's a little more for if you're comfortable using Swift. They do some nice stuff. It's a little scary, but it is nice. Some of the generic things they use sort of I found quite hard to understand. But some of they've got some really nice examples in there of code you can use to tidy up some of the work you do with core data. Some of it's still valid, some of it isn't so much, but it's actually a really nice book to have. I have both. They're quite nice to dip in and out of. So just in summary, core data is hard, but it is getting easier to use. I mean, I've worked with core data apps. All the apps I've worked on by myself that have had persistence, I've put core data in. I think all but one of the apps I've worked, two apps I've worked on a team have not had core data in. One of them has had Realm. As I said, that went quite well. It is evolving. Swift support is really coming along. I wish I was using core data in my current job, which I'm not, but hopefully I'll be able to squeeze some of that in. And I'd really like to try these new capabilities. I hope you are too. Thank you very much. I think I finished faster than you expected.
So once again, thank you for being here.
Talking about Swift, like it seems that you can do obviously core data with Swift, but how does it feel like? Is it Swifty, like to take the word that we like, or is it like just an old API that is like chunky, or
it's an old API that's a bit chunky.
Okay.
The new stuff they're putting in, I think, makes it Swifty, but really, Swift functional programming model, immutable. Yeah. This isn't any of that. These are references. Mm-hmm. That's not to say you can't use them as value types, because if you have an object that you just want to do something on, but you don't want to change the object that you're working on, so to speak, you can push that to a child context. You can manipulate it in the child context. Mm-hmm. And if you want to, you can change it back, you can save it back, or you can dump it, or you can send it somewhere else. So you sort of get copying, if you want, in a way, in a lightweight way. Yeah. I think the API, in some of the ways they do things, it's still very wordy. They haven't changed a lot of the naming. I don't think they've had a grand renaming on it. Mm-hmm. So as you can see, some of the slides I had to format differently so it would work. Yeah. But it's a very old, very well-established Objective-C API.
Yeah, but the good thing is that you're kind of saying that they are trying to adapt new things to Swift, so it means that it's not actually dead at Apple. Because, I mean, the fact that they deprecated the iCloud support is really scary, because when you try to, when you want to write an app and use core data as the core of the app, and you're thinking, oh, will they, in some kind of sneaky update, deprecate all core data? And what do you do?
In,
Do you think it could happen?
in Apple's defense, iCloud never really worked.
And why?
so maybe-
That was like the
So maybe they're just saying, look,
recurring
forget
problem.
it. You know, it's
Yeah.
we're not going to keep pushing you to use this. Maybe they'll come up with something else, or maybe they'll say it's going out the way. That's not. I mean, not all apps need to have core data. Lots of apps do not. Lots of apps work perfectly fine without it.
Yeah.
I just think if I've got an API that consumes, because these are the sort of apps I've written in the past, which just takes a load of data off a REST API, dumps it in a table view. Sometimes you manipulate it, sometimes you don't. It's so much easier to use. Easier to use than anything else. The change management alone
Yeah.
itself, the ability to save on the background queue.
Yeah.
At the beginning of my iOS years, I did that. It was actually really a news feed app that was reading a REST API and putting all that into some core data back, and then reading back from core data. So I had those problems with the crash with data was but it seems a bit like weird doing that, but at the time I can now remember that it was really handy because of the fact that it's updating itself, and you cannot get the same feeling as with when you use something like reactive, or you have this kind of feeling that things are like
The changes are pushed out
they
you.
push to your UI,
Yeah.
and you don't have to pull. And
Yeah.
you still have that, and
I do. I think core data gets a really bad rap because
yeah.
it's easy in a way to use it. The hard bit comes in tweaking it to do what you want it to do. I mean, I've had problems saving in a background queue, really difficult, because you save it, it's still got to propagate change to the main context,
Yeah.
and if you do it in too big, it'll block your main UI for too long. So you do it in batches. How big a batch do you do? You can only really profile it. You know, I've been able to do some really fast things in core data, and I've done things badly, and it's been horrible.
Yeah, and did they update that? Did they improve this batching, blocking?
Hopefully,
Maybe with the
No.
performance. Oh, okay.
no, but the ability to get a different, because if you read the literature on it, there's lots of ways that people have done with the different stacks. So you don't block the main queue, you have all these other trial private context on it. But there was always the trouble of you need objects from another context, and it was done by manage object ID. And if you know what I'm talking about, you realize it's not permanent until it's saved, and if it's saved, it's changed.
And it's really tricky code,
Yeah.
like when you start implementing that.
Yeah. Speaking of tricky, there are lots of persistence frameworks out there, but
Really?
yeah, I know a couple. I guess core data is one, and there was another one starting with R. But anyway, but do you think we really need a persistence framework to do persistence? Like, can't we use sometimes just URL caching, fine-tuning it, and forget about real persisting with frameworks?
Sorry, what kind of caching? Just in memory?
Yeah. Oh, yeah. URL caching, for example.
Oh, off the web server.
Yeah.
Yeah. Yeah, but then will it work offline? Will it handle as much data as you can put into a core data store? Will you be able to react to changes in it as well as you can off a real live updating app?
But the problem is also that at the beginning of the project, you don't really know how much time it's going to cost to add this layer of core data, and sometimes it's quite big, and it's as usual measuring the size, the amount of time you're going to spend in the implementation of the feature is always hard to do. So you don't know when it's going to be useful. So do you have a rule of thumb or some ideas on where it's going to become really useful?
Rule of thumb.
Because, like, I mean, we've all, like, most of us drop core data, so we don't know if it's like.
I use core data when I can. If I'm doing any kind of persistence for an app, I'll use core data. It's just for simple apps, for something like setting up a simple stack, using the main queue is perfectly fine for a lot of applications. You don't need the background stuff, and it's easy to set up, easy to model. Migrations handle for you. The app that I use Realm on, we were unsure whether to use Realm or core data, and we did that also because the app helped that way because it was just completely static data. We did it through a facade, so we persisted the objects in Realm, but we actually used objects that we took from Realm, converted into our objects, and used them that way. The idea was if you wanted to, we could change it to core data in the back. We just never needed to, rather.
Yeah. Okay. I have another question from the audience. how do you deal with non-generic NS ordered set? It's a pretty specific question.
I don't use NS ordered set. It's the best of both worlds. I have no idea about the non-generic NS ordered set because I don't use it.
That's probably a question that you guys will be able to ask at the classroom or later.
No, look it up, but I just don't use a generic ordered set.
Did I get right? Like this new pin controller is really like you kind of take a snapshot of your data and then you display that without having the risk of any fault or any crash?
That's what we're
Is
told.
that cool?
Yes.
Oh, that's
Yeah. And you can actually pin it, so you can actually pin it to a value and not change it, so it's always there. But in the sense of if there's no context holding onto a pin, all that sort of memory that it's, or the cache that it's using isn't actually kept. So it's really only if you say I'm pinning to something, it worries about pinning it. So it's not like
that's
a transactional store of everything. If you're not using it, it's not doing it.
Oh, that's
And it doesn't sort of say that
really
you have it pinned at this version, you did this change, this change, this change. You've got 3 things. It's basically next time you ask for one, it takes that one.
okay. So thank you very much.
Yeah, thank you.
Thank you for being here.